You are welcome to the GMAETS 41's live class today. So we are going to look at matrices and determinants in mathematics. For those preparing for JAMB, you know that if you're sitting for JAMB, we have maths generally. If you're preparing for WAEC, then we have that called general maths, and we have further maths. For those preparing for further maths, you will encounter matrices and determinants. Is that okay? That's those that are taking further maths in their WAEC examination. Then for JAMB, what you're taking is generally maths. There is nothing like further maths, general maths there. So once again, you're welcome. Mercy, you're welcome to the class. So remember, if you join the class, give this lesson thumbs up, and then you can indicate I can hear, so that I kick off the class fully. If you can hear me, indicate I can hear, so that I can kick off the class right away. Queen Omar, good evening. You're welcome to the class. Henry, good evening. Welcome to the class. Please, can you hear me from your end? If you can, indicate. Type I can hear, so that I'll kick off the class right away. It's important to indicate that you can hear me, all right, so that I kick off the class. For there is no need kicking off the class when you cannot hear. All right, Queen Omar, thank you for indicating that you can hear me. And once again, welcome to all of you who have connected to this class. So we are looking at matrices and determinants, and we have a couple of questions we are going to solve. But before we move on to these matrices and determinants, as always, I'm going to give a quick summary. And when we talk about matrices, it's simply a rectangular array of numbers in rows and columns. I'm sorry, I'm battling with my voice at the moment. So if I give you something, a mathematical expression where this expression is arranged in rows and columns, we refer to that as matrix. For example, if I give you A11, A12, A13, and that continues, and continue to A1n, I give you A21, A22, A23, it continues to A2n, whomever that is giving you this stuff wants you to stop. And then let's have A31, A32, A33, continues to A3n. This can continue to AN1, AN2, AN3, and continue down to ANN. This arrangement of elements in rows and in column is what we call matrix. So these are the rows, the horizontal arrangements, they are the rows. Then the vertical arrangements are the columns. Is that okay? Then these terms we have inside are called the elements of the matrix. The element of what? The matrix. Is that okay? They're called the elements of the matrix. So that is it. This arrangement is what we call matrix. So for example, I can give you something like 2, 3, 0, 1 minus 5k minus 2. Can give you 0, 0, let's say 10. This is a matrix. How many rows do we have here? 1, 2, 3. And how many columns do we have? 1, 2, 3. So you see, this is row 1, this is row 2, this is row 3. Then, of course, this is column 1, column 2, column 3. You can see that. Is that okay? So that's what we mean by, rows and columns. And these numbers written inside are called the elements. So we have 230. 230 are elements in row 1. But you can see that 2 is in column 1, 3 is in column 2, 0 is in column 3. They have 1 minus 5 minus 2, they are in row 2. But 1 is in column 1, minus 5 is in column 2, minus 3 is in column 3. Similar to the last row, row 3, all these elements are in row 3. But this 0 is in column 1, this 0 is in column 2, this 10 is in column 3. Now we use the rows and the column to identify an element in a matrix. We use the rows and column to identify elements in a matrix. If I tell you to identify elements in row 1, column 1, for example, you will come to row 1, look at it, check it with column 1, look at it. You will notice that if I happen to, let's say I draw this line across row 1, column 1, you'll notice that they will meet, the two lines will meet across this element. So this element 2 is the element in row 1, column 1. You get that right? So if I tell you, okay, identify the elements in row 2, column 3. Row 2, column 3. Just come to row 2. This is row 2. Column 3. This is column 3. The two lines cross over this minus 2. So minus 2 is the element occupying row 2, column 3. How about I tell you to identify the element occupying row 3, column 2? Simple. Row 3, column 2. This element. Is that okay? Row 3, column 2. The two lines went across each other on this element 0. So the element that occupies row 3, column 2 is 0. This is how we identify the elements of a matrix. This is how we identify the elements of what? A matrix. Some of you are just so funny. Cartoon Dunia, please, sir, tell me what is 1 plus 6. If I tell you the answer of 1 plus 6, are you sure you would like it? What if I tell you that 1 plus 6 is 70? Or it is 5,000? Okay, let's move on. 1 plus 6 is 7. Just be there and catching fun with your question. Now, I have introduced the concept of matrix, how you identify the elements and other things. Now, let us talk about the order of a matrix. The order of a matrix. The order of a matrix is simply obtained from the number of rows and columns that the matrix has. Like this matrix now, how many rows do we have? 3 rows. How many columns do we have? 3 columns. So this matrix is known as a 3 by 3. You quote the row first. You quote the row first. If you want to know the order of a matrix, order of a matrix, you quote it row by column, row by column, row by column. This row by column, we write it as row, then cross. Instead of writing by, I can just say, okay, R by C. Row by column. This multiplication sign is pronounced by. So like this matrix now, the matrix above, this is matrix of order. Let me indicate the order. Since the rows and columns are the same in number, we can just simply call it matrix of order 3. Order 3. Because the rows and the columns are the same. And such matrix in which the rows and columns are the same is called a square matrix. It's called what? A square matrix. This is a square matrix. Square matrix. This is a square matrix. This matrix. Reason, the number of rows and columns are what? The same. All right, having said this, let's take a look at this matrix. If I give you 1, 2, 5, 3 minus 8 and 9, let's say that I tell you that this is matrix A equal to this. And I'm asking you what is the order of this matrix. Order. To get the order is simple. Just count the number of rows and the number of columns. So how many rows do we have here? We have 2 rows. This is row 1. If you want me to indicate, I can indicate. This is row 2. And then here we have column 1, column 2, column 3. It's not necessary to label all these things, right? It's not necessary. This is something that you can easily identify. Okay? So we have 2 rows and 3 columns. Therefore, the order of this matrix is 2 by 3. 2 by 3. This is a 2 by 3 matrix. This matrix is not a square matrix. This is not a square matrix. Take note. And why can we say that this is not a square matrix? It is not a square matrix because the number of rows and the number of columns are not the same. They are not the same. The number of rows and the number of columns are not the same. All right? But you've known how to get the order of a matrix. Now, if I ask you to tell me the element of the matrix that occupies row 2, column 2, the element of the matrix that occupies row 2, column 2 of this matrix A, you'll agree with me that this is row 2, this is column 2, row 2, column 2. The element that occupies that is -8. Knowing how to identify the elements of a matrix is very important. Very, very important. Because when we enter operations on matrices, right? You know that you need this guy to be able to get certain things. So this is cool. All right. Classical introduction to what you should know about matrices. I've told you about square matrix. Any matrix that the rows and columns are the same is called a square matrix, right? I've told you the order of a matrix. The order of a matrix is simply number of rows by number of columns. I've also explained to you how to identify the elements of a matrix. Now, what are the operations you can carry out on matrix? Operations you can carry out on matrix. I hope this has not cut off from view. Okay, good. Operations on matrices. So what are the mathematical operations we can carry out on matrix? 1, we can add matrices. Addition. You can add 2 or more matrices. 2, you can subtract 2 or more matrices. Subtraction. Then 3, you can multiply matrices. Multiplication. You can multiply matrices. These are the operations, all right? The arithmetics that we carry over or we carry on matrix. We carry out on matrix. The operations we carry out on what? Matrix. You can add or subtract 2 or more matrices. You can multiply 2 matrices. 2 or more matrices. Now you cannot divide a matrix by another matrix. Take note of that. You cannot divide a matrix by another matrix. Therefore, the operation of division on matrix is not possible. If maybe say you are given 2 matrices to divide, you cannot do that. But you can divide a matrix by a scalar. That is to say, dividing a matrix by a given number. You can divide a matrix by a given number. Like this one here, I can decide to divide this matrix by, say, 2 or 3 or whatever. But you cannot divide this matrix by this matrix. It's not done. So take note of that. All right. We are going to look at questions on all this. What other things should you know about matrices? How to transpose a matrix? You should know that. How to transpose a matrix is important for you to know that. To transpose a matrix, you simply change the rows to column. To transpose a matrix, you simply change what? The rows to columns. Like in this case, this is row 1. take that row 1 and then, right? Change it to become column 1, which means you're going to have 2. This 3 will come here. This 0 will come here. Then you pick row 2. Right? Turn it to column 2. This 1 will come here. This -5 will remain there. Then -2 will come here. Then you pick row 3. Turn it to column 3. This 0 will come here. This 0 will come here. 10 will remain here. That is how we transpose a matrix. And if I tell you to maybe the symbol we use for transpose of a matrix, if I have matrix A and I say you should transpose it, you simply do this. Are you following, right? So you should know how to transpose a matrix. Very important. Then, of course, you are expected to also prepare for inverse of a matrix. You should know how to also evaluate equal matrices. So you want to take note of that, okay? You want to take note of that. So let us talk about equal matrices first. Let me give you an idea of what equal matrices are. When matrices are equal, then their corresponding elements are considered to be equal. I'm going to give you an example. If I tell you that matrix A is equal to 2, 3, 4, let's say -1, 0, -7, let's say 8, 9, and then let's say this is 11. And then I give you matrix B to be equal to X, Y, 4, -1, 0, -7, then A, B, C. Now, if I tell you that if A is equal to B, if matrix A is equal to matrix B, it simply means that their corresponding elements will be equal. What do we mean by their corresponding elements? That is why you should know how to identify the elements of a matrix. This 2 occupies row 1, column 1. This element 2 in matrix A occupies row 1, column 1. So these 2 must definitely be equal to the elements that occupies row 1, column 1 of B. If and only if matrix A and matrix B are equal. So if you're telling me that A and B are equal, it therefore means that this element in row 1, column 1 of A is equal to the element in row 1, column 1 of B. The same thing, look at this element in row 1, column 3, which is 4 of matrix A, will be equal to the element in row 1, column 3 of matrix B. And you can say that they are the same, 4, 4. Look at the element in row 2, column 3 of matrix A, -7. It will definitely be equal to the element in row 2, column 3 of matrix B. You can say that -7. Now, what is the value of this B? This B is an element that occupies row 3, column 2. Row 3, column 2 of matrix B. The element there is B. Therefore, if matrix A and B are equal, then this element in matrix B, which is element in row 3, column 2, will be equal to the element in row 3, column 2 of matrix A. And that element is 9. So B is equal to 9. An examiner can give you this, which even depending on the way they present the question, can lead to simultaneous equation, and then you solve for unknown there. It's possible. So I want to take note of that. All right, so for 2 matrices to be equal, like in this case, if A is equal to B, now it implies that, okay, like I said, X will be equal to 2. Corresponding elements will be equal. Elements that occupy the same position in the matrix, right? They will be the same, they'll be equal. So the next one, I have A. A is equal to what? A will be equal to what? You compare it to matrix A, and then you find out that A is equal to 8. Element in row 3, column 1. Then B is equal to 9. And then C is equal to 11. So this is the condition for 2 matrices to be equal. Their corresponding elements must be equal. we are moving on. Finish up what you have on the board. Let me wipe it. And then we now talk about determinant of a matrix, as well as we'll talk about the adjoint of a matrix. You should know about that. And we'll talk about inverse of a matrix. After that, we pick questions and solve. So finish up what is on the board. You can decide to screenshot so that we move on to the next thing of interest. All right, so I hope you are done. So the next thing you want to give attention to is determinant of a matrix. You should know how to evaluate the determinant of a matrix. I would demonstrate something for you. I'll just demonstrate something for you. And always remember that, bear it in mind, so that whenever you have to find determinants of a matrix, you always remember to do that. So like I said, you should know how to obtain the determinant of a matrix. To get the determinant of a matrix is simple, right? Just remember, at every point in time, you do this. This is what I've done, right? It's just a very simple stuff. It requires you to multiply and subtract. Multiply and subtract. So let us assume I have 1, 2, and I have 3, let's say, of 0. And I say you should find the determinant. So simply multiply this by this. This is the first multiplication. Then next, multiply this by this. This is the second multiplication. You see that 1 times 0 will give you 0. So that is this multiplication. Are you getting me? And that's the first thing you do. Remember, I told you I did something like this, right? So you start from the right first, okay? This right movement, which is left to right down. 1 times 0 is 0. Then minus 3 times 2 is 6. So the determinant of this guy is simply equal to minus 6. This matrix is a 2 by 2 square matrix. 2 by 2, so it's a square matrix. You can be asked to find the determinant of a 3 by 3 matrix. Let's assume I give you something like this. 1, 5, 2, minus 6, then 4, let's say minus 1. Then let's say that I've got 3, 7, and then 8. For 3 by 3 square matrix. By the way, know that whenever we are talking about the determinant of a matrix, you usually obtain determinant of square matrix. Square matrix. A matrix that is not a square matrix, we don't obtain the determinant. In fact, it's not possible to get the determinant. So the matrix has to be a square matrix first before you get your determinant. For 3 by 3, if you are to get a determinant, you are expected to do something to reduce it to 2 by 2. Because in all cases, to get determinant, you have to do this. This first and then this. Do you understand that? And for us to reduce this to a 2 by 2 square matrix so that we can find the determinant, there is a standard sign convention you must apply. Plus, minus, plus. You must fix that thing. So that in each case, you pick this element. If you pick that element, the row and the column will disappear, right? You just wipe it off. You see, when I pick this one, the row goes off, the column goes off. But please don't go and cancel it down. Use your mind eyes to eliminate that row and column of that one. You'll be left with 4 minus 1 and 7, 8. Then you do this. Any value you get, use it to multiply that plus 1. Next, you pick the second guy, which is minus 5. Delete the column, delete the row. When you are deleting, like I said, don't go cancel anything. Use your mind's eye. If I pick minus 5 and delete the column, delete the row, you'll be left with minus 6, minus 1, 3, and 8. Then you run minus 6 times 8, which is minus 48. Minus 3 times minus 1. 3 times minus 1 will give you minus 3. So you now get something like minus minus, which is plus. So this is going to be minus 48 plus 3, which is going to give you minus 45. Then multiply by this minus 5. And then finally, pick this last one, plus 2. Repeat the same thing. Delete the column, delete the row. If you do that, this column goes off, this row goes off. You'll be left with minus 6, 4, 3, 7. And then repeat the same multiplication. Minus 6 times 7 is minus 42. Minus 3 times 4, which will give you 12. So minus 42 minus 12, whatever you get, multiply by these 2. Then simplify that. The answer you get is your determinant. So you see that you have to reduce that 3 by 3 matrix. There's something, a procedure you have to follow to reduce it to 2 by 2 so that you find the determinant. All right, so having talked about the concept of how to obtain determinant, there are some things I need you to know. There are some things I need you to know about determinant, right? There are some things I need you to know about determinant. One thing is, if determinant equals 0, if determinant equals 0, comma, the matrix is said to be singular. The matrix is known as a singular matrix. Is known as a singular matrix. So you take note of that. You are asked to evaluate the determinant of any matrix, and you find out that the determinant is equal to 0. That type of matrix is known as a singular matrix. In fact, that idea is used sometimes to obtain the value of an unknown in a given matrix. Let me assume I give you 1, 2, 3, 4, 5, 9, x, 6, and 2. And I tell you that the determinant of this is equal to 0. Find x. You can use this knowledge to get the value of x. Simply work on the determinant. Remember to do that plus minus plus because this is 3 by 3. Once you get the determinant, equate it to 0 and you solve for x. With that, you can get the value of x. You can get the value of x. Franz, column transformations. Column transformation is when we move on deeper into matrix, because where you'll be talking about echelon matrix. That is beyond the scope of what I want the GMAT 41 students and everyone connected to this particular class to know. I'm preparing students for JAMB and for WAEC, although advanced level 100 level still needs this. 200 level as well to a linear algebra. Linear algebra. Need this concept of matrix, and of course there we talk about the row transformation and stuff like that, where we introduce the concept of echelon matrix, Gaussian elimination, triangular decomposition, and the rest of them. But that's not the focus of this particular class. On the GMAT 41's channel, this particular channel, if you slide through to the GMAT 41's playlist, you will meet Math 201 linear algebra, and there you will see the concept of what you just referred to. Okay, but that is beyond what we are to give attention here. All right. Now, I've told you this this point about matrix. You want to take note of it. You want to take note of it. No need of numbering this as number 1. I don't think I want to tell you any further thing about matrix, about determinant for now. Yeah, I don't think so. I think this is sufficient. Then when you talk about different types of matrix, there is this matrix we call diagonal matrix. Diagonal matrix only have elements along the leading diagonal, right? Along the main diagonal. For example, if I give you something like 1, 0, 0, 0, 2, 0, 0, 0, 5. And I tell you to find the determinant of this matrix. This matrix has a name. The name of this matrix is called diagonal matrix. Diagonal matrix. If you are giving something like this in exam and you're asked to find the determinant, don't punish yourself doing plus, minus, plus, and then, pick this element, delete row and column, multiply this by this, minus this by this. Don't bother yourself. To get the determinant of this, the element along the main diagonal. This element along the main diagonal, 1, 2, 5. Multiply them. So the determinant of a diagonal matrix is equal to, in this case, you multiply 1 times 2 times 5. That's going to give you 10. That is the determinant of a matrix called diagonal matrix. Diagonal matrix is that matrix that has non-zero element along the main diagonal. The other element below and above the main diagonal are 0. The other element below and above the main diagonal are zeros, like you can see. So you get a determinant, just multiply the element along the main diagonal or the leading element. Okay, so that is it. Now let us talk about the adjoint of a matrix. Adjoint of a matrix. You're expected to also know that adjoint or transpose of the cofactor of a matrix. Okay, now I'd like to say something because of the exam I'm preparing you students for, right? The class we are having presently is not just about giving the whole knowledge and other things about a particular topic. We are hitting main things students want to give serious attention to. Like I said on this channel, you see all these works have been covered so much. I've got wonderful academic video lessons for these stuff, where I broke concepts down one after the other. In fact, you can even have a topic that has up to 2, 3, 4 video lessons that make it up. Go to the playlist on this channel, you'll see these stuff. Now, why I'm saying this is that I have adjoint or transpose of the cofactor, adjoint or transpose of the cofactor of a matrix. Because of the exam we are focusing on right now, which is JAMB and WAEC, as the case might be. Like in JAMB, your examiner limits you to 2 by 2 square matrix if it is necessary for you to find the inverse of the matrix. You are not being tested on 3 by 3 square matrix in the case of the inverse of a matrix. And for JAMB, you are not even asked to find the cofactor of a 3 by 3 square matrix. You are not asked that. For that reason, I'm sorry that, am I really sorry? Do I owe apology for that? The truth is, the exam we are preparing students for right away, which I've mentioned, the exam, they don't need this. So I owe you no apology. I take my apology back. To get the adjoint or the transpose of the cofactor of a matrix for a 3 by 3 square matrix, slide to the GMAETS 41's playlist, this channel, locate Math 201 linear algebra. Scroll through, you would see video lesson on matrix of minor and matrix of cofactor that actually dealt with 3 by 3 square matrix, even not 2 by 2. But in this particular live stream class, I'll focus on 2 by 2. How do we get the adjoint or the transpose of the cofactor of a matrix? It's simple. We have to get what we call the matrix of minor first. The first thing you do is obtain the matrix of minor. Obtain matrix of minor. Obtain matrix of minor. Then 2, apply the standard sign convention. Standard sign convention. Standard sign convention. Standard sign convention. At this point, because I am not going to focus on 3 by 3 square matrix, you may not anyway. Well, I don't know. Let me just say you may not know much about how to obtain the matrix of minor of 3 by 3 square matrix, because I'm not even going to bother myself on showing you how to obtain the matrix of minor of 2 by 2. I'll just show you the shortest cut of doing that if you're in examination hall. But if it is 3 by 3, you don't do that trash, right? Yeah, you don't do it. So apply the standard sign convention. What do we mean by standard sign convention? Apply the standard sign convention on the minor, on the matrix of minor. Matrix of minor. Now the standard sign convention, like if it is 3 by 3 square matrix now, by the time you obtain the minor, from the first element, you start applying this plus, minus, plus. Let me just show you that. Let's assume that the matrix of minor, for example, say a 3 by 3 square matrix. You have gotten the matrix of minor, and let's say the matrix of minor are 1, 2, 0, 4, 5, minus 8, minus 1, minus 5, and then 3. If this is the matrix of minor, to get the matrix of cofactor, apply the standard sign convention on the matrix of minor to get the matrix of cofactor. Matrix of cofactor. Good. So this is what you do. Come over to this, and then you introduce plus, minus, plus, minus, plus, minus, plus, minus, plus. So you see the alternating sign convention. It's a standard. You expect to know that anyway. But like I said, I'm not focusing on 3 by 3. But I've just shown you how to get, to apply the standard sign convention. If this matrix is matrix of minor, for example, of a given matrix, then you are meant to apply this plus, minus, plus, minus, plus, minus, plus, minus, plus. Is a standard. But if it is 2 by 2, this is for 3 by 3. Now for 2 by 2, this is how you pick the standard sign convention you apply on the minor. This part is what you use. Plus, minus, minus, plus. So if, for example, I have matrix of minor of a 2 by 2 square matrix to be, let's say 3, 7, and then 5 minus 9. Let's say that this is your matrix of minor for a 2 by 2, 2 rows, 2 columns, right? To introduce the standard sign convention on the matrix of minor so as to get the matrix of cofactor. See this plus, minus, whatever I did here, I've actually gotten the matrix of cofactor. Are you following? Now to get the matrix of cofactor here, cofactor of A will now be equal to this same thing. Then you introduce your standard sign convention, 3, 7, 5, and then minus 9. Watch. Plus, minus, then minus, plus. That's the standard sign convention. Now once you do this, you have gotten the cofactor. Sorry that I still maintain minor here. So let me change this now to cofactor. Let me change it to cofactor. Because the minor alone is this 1, 2, 0, 4, 5, minus 8, minus 1, minus 5, and 3. Once you introduce this standard sign convention, right, it converts that matrix of minor to matrix of cofactor. So this one matrix of cofactor of the 2 by 2 square matrix. Once you obtain the matrix of cofactor, the last thing you now do, step 3. Remember, we are trying to emphasize or maybe highlight the steps of obtaining adjoint of matrix. Step 3 now is transpose. Transpose the matrix of cofactor. The matrix of cofactor. Once you transpose it, that is the adjoint. This is the adjoint of the matrix. So the transpose of matrix of cofactor is the same as the adjoint of that matrix. Like in this case, now this is matrix of cofactor. If you transpose this, how do you transpose? Change the rows to column. Like this, now this is row 1, 3, 7. You change it. Let me write this CA transpose, which is the same as adjoint of that matrix A. Adjoint, abbreviated as ADJ. Come over here and then transform. Row 1 will become column 1. So you have 3 and 7. Turn it. Then row 2 will become column 2, which would give you, this 7 is minus 7, minus 7, because this minus will affect it. Then this is minus 5, and then plus times minus will give you minus. Plus times minus will give you minus. So we have minus 5, and then we have minus 9. I have transposed it. I've transposed it. But I'd like to tell you something. This matrix of minor, we have it here. The cofactor is this, right? Now for the minor, how we obtain the minor from the matrix itself is just to switch. Don't worry, we're going to see that when I do that on the board. You do some diagonal switching. Can we use calculator for it? You can use calculator. However, Issa Abdul Aziz, may we avoid getting too lazy. Let us avoid getting too lazy. And it's important for us to understand something. Most of the exam bodies now, if you're talking about professional exam bodies, they prevent students from using calculators. You know that. They prevent students from using calculators. Like in JAMB now, if you are sitting for JAMB, which calculator would you use to solve matrix, for crying out loud? And please, from the GMAETS 41 here, I advise, and as a good coach, because I see you friends as my brothers, my sisters, so sometimes I go to warn. I want students to try to reduce their dependency on calculator. Stuff that you can do without calculator, please do them without calculator, except it becomes absolutely necessary. Using calculator in matrix, for me, it's lazy students that do that. These things are very simple. And let me tell you, calculator is a machine. It is a garbage in and garbage out stuff. When you are pressing that, someone that is very good in basic arithmetics, you know how to play with numbers and the basic arithmetic sign, plus, minus, times, divide. The time it will take you to start imputing all these, elements into the calculator, because of course you have to set the calculator mode to matrix, and you don't use anyhow calculator, you use super calculator. This calculator does that. You can't use anyhow calculator for for that conversion. That time it will take you to do the conversion, setting the mode of the calculator, imputing these values. Someone who is very fast in basic arithmetics and understands matrix is done with it. Therefore, in as much as you can use calculator for this, GMAETS 41 strongly discourages that. I have my reasons. One of it is because, number one, it makes students to be lazy. Number two, it makes our brain to be dull. Number three, most of the professional exam bodies now, once you go in for the exam, they deprive you from using calculator. All right, let's move on. So, copyright what is on the board. Let me wipe it. You can screenshot. So that we move on to the final thing I want you to know before calculation, which is inverse of a matrix. I believe you have finished up. So, let's move on to inverse of a matrix. You see the steps I've taken you through. It is because of certain things that we need. Inverse of a matrix concludes this whole thing as per what you are expected to know as you are preparing for your examination. Is that okay? Now, how do we obtain the inverse of a matrix? Inverse of a matrix. For the exam you are going for, like JAMB, they restrict you to 2 by 2 square matrix if they are asking you to get the inverse. Assuming that you have matrix A and you're asked to obtain the inverse of the matrix A, the inverse of the matrix is given as this. This is the symbol we use to represent the inverse. So if it is matrix C, that will be C raised by minus 1, right? Yeah, the inverse. That's how we write it. And to calculate the inverse of a matrix, it is 1 divided by the determinant of that matrix. 1 divided by the determinant of that matrix. Then you multiply it by the adjoint of that matrix. Multiply it by the adjoint of that matrix. And don't forget, The adjoint of a matrix is the transpose of the cofactor of that matrix. Transpose of the cofactor of that matrix. I just showed you the steps of obtaining adjoint of a matrix. So once you know the determinant, you know the adjoint, multiply the adjoint by the reciprocal of the determinant, and your result is just there for you. So guys, I am done with the summary work on matrices. See, it's really a simple topic, okay? Yeah, all new students that just connected, you're welcome to the class. Nanen, good evening, you're welcome. Joy, good evening. You're welcome to read to the class. First key, the answerer. Thank you for supporting what my response to Issa Abdul, right? Indicating that what I said is a pure fact. Okay, so it is time for us to pick questions now, right? It's time for us to pick questions. And we have a very first question here I'd like us to deal with. Question 1. I am going to pick just any question. This is no time to like, okay, let's solve questions on addition, let's solve questions on subtraction or whatever. I will put questions randomly. That is why I gave the summary of this, so that whatever I am solving as a question, you can actually follow through with what we're doing. Now, I've got this question here, and then we're going to solve it. Let's see what we've got there. So the first question I have here, the examiner asks us to obtain this. The question reads, the determinant of the matrix. The determinant of the matrix 1, 2, 3, then 4, 5, 6, 2, 0, minus 1. The determinant of this matrix is what? So we have the options provided alongside. Option A, minus 67. Option B, minus 57. Option C, minus 3. Option D, 3. Once again, option A, minus 67. Option B, minus 57. Option C, minus 3. Option D, 3. So what is the determinant of this? This is 1 plus 1, like I said. See, dear friends, the thumbnail to this particular live class, you know, that you saw, I read somewhere, okay, blast your 100 over 100 in math. See, it is quite easy to blast 100 over 100 in math exams. You see, math is simple and interesting. But one thing about this subject is, yeah, it's simple, it's interesting, but it's one of the most important subjects you can think of, because when it comes to brain development, math is one of the best subjects that can do that for you. So you don't play with math. I know that some students, they have this phobia for math and other things. Relax. There are factors that lead to that. It could be that you yourself, you are closed-minded, like you've decided that I say math is not for me. Or it's about the educators that you encounter, maybe your coach or whatever, the manner the person is presenting it. Because of course, I know some persons make others, some people that educate, make others feel that math is something that it's only some set of people that math is meant for. Hey, listen, I'm telling you, GMAETS 41 is saying this. Math is one of the most simplest subjects you can think of, because it's just one directional. Once you know it, you know it. Just go that way, right? So you want to be confident. This thing is 1 plus 1. For those preparing for JAMB, I want to assure you, if you're taking math is one such subject. If you were prepared, you follow up with our classes as I'm coaching you, do your own personal studies, you can be sure that you can blast 100 over 100 in math. Yeah, it's possible. It's possible. So I wasn't joking when I wrote that. If you come to physics, I had not written such before. Chemistry, I had not written such. English, I had not written such. What I write most times, they're okay. Maybe blast 90 plus. Because I just have to be honest. In as much as those subjects are still a go, it's easy, someone can blast very high. The truth is, chances of smashing 100 over 100 in such subjects is a bit low compared to maths. I must assure you of this. Let us see how we play along with this. This is a 3 by 3 square matrix. As you can see, we are asked to find the determinant. This slash line, you see this slash line, it represents determinant. So I am given 1, 2 and k. In fact, in exam hall, I don't, must I show the work? I don't need to. This is the question. Let's do it once, please, no time. See, I'll come over here as I'm solving plus, minus, plus. Then pick the first guy, plus 1. I'm solving for the determinant now, determinant of that guy. We use that to abbreviate. Determinant is equal to, if they had labeled this matrix, let's say matrix A, I'll write that A, or I'll put that A in slash sign like this. This means determinant of A. All right, so picking that one, we are going to get positive 1, open bracket. Now watch. Delete the column, delete the row. If you delete the column and the row of this element, you'll be left with 5, 6, 0, and minus 1. If you are left with 5, 6, 0, and minus 1, do this. This first, then minus this. 5 times minus 1 will give you minus 5. And then 0 times 6 will give you 0. But before you do this times this, fix minus. Because when you are doing this, it's going to be this minus this. So this is going to be 0 times 6, which is 0. Next, you pick minus 2. Delete the column and the row of that minus 2. If you delete the column of minus 2, delete the row of minus 2, you'll be left with 4, 6, 2 minus 1. 4 times minus 1 will give you minus 4. Then minus 2 times 6, which will give you 12. Finally, pick plus 3. If you pick plus 3, repeat the same thing. Delete the column, delete the row. You'll be left with 4, 5, 2, and 0. Then 4 times 0 is 0, minus 2 times 5 is 10. Simplify this. This is basic maths and basic arithmetics. Remember, the GMAT 41 has a channel specially dedicated for our basic scholars. What's the purpose of this channel? To build and improve students' knowledge in terms of basic arithmetics, terms of English language, in terms of basic sciences. And I believe in one thing, I've always said it in several of my videos, your basic arithmetics knowledge, don't joke with it. Once you conquer that, you are stabilized in anything calculation. If you have problems with that, then that is when you'll be complaining of all these small things. Simplify this. Minus 5 minus 0 is minus 5. Multiply the minus 5 by 1, you get minus 5. Simplify this bracket. Minus 4 minus 12 will give you minus 16. Minus 16 times minus 2 will give you plus 32. Simplify the 0 minus 10, you get minus 10. Minus 10 times plus 3 will give you minus 30. 32 minus 30 will give you 2. 2 plus minus 5, or simply minus 5 plus 2 will give you minus 3. So this is the determinant of that matrix. And from the option provided, option A is 67, option A is minus 67, option B is minus 57, option C is minus 3. And of course, that is the answer. Option C is the correct option. So we are done with this question. If you have any question on that, you can ask. Remember, you can support this channel with whatever is convenient for you. To do that, you have on the chat section, the chat box, that chat box there, right, where you post your comments and other things. By the right, you would see your currency icon. Click on that currency icon. You can support GMAT 41 by sending GMAT 41 a super sticker or super chat, or you can become a channel member. That channel membership, very important. You can benefit so much from that. Join GMAT 41 on platinum or diamond level. Platinum level is 2,000 naira Nigerian currency monthly. So do that, you can make payments, all right, online there, and become a channel member. That is a monthly payment. So you see very little. A monthly payment, 2,000 naira. And you learn something very wonderful. You have access to all our video lessons. You ask questions, your questions are being prioritized, you know, and of course, much more benefits, especially for members. Now we are done with this, and that is what you should know about determinants of a matrix. Very simple, nothing is there. Okay, nothing is there. Most times your examiner asks question on this determinant. And they're asking you determinant of a matrix. Most cases they give you 3 by 3 square matrix to find the determinant. Because for 2 by 2 is very simple, right? Okay, let's move on to another question as we may have here. I don't need to solve any other question on determinant, it's not necessary. Now look at this one. Question 2. We have this question: if minus x 12 minus 1 4 equals minus 12, find x. If this is equal to minus 12, find x. Option A, we have 6. Option B, minus 6. Option C, minus 2. Option D, 3. So it's a simple guide to deal with. This slash sign I've told you represent determinant. This is a 2 by 2 square matrix, 2 rows and 2 columns. The examiner is now telling you that if you evaluate the determinant of this matrix, you are expected to get minus 12. Upon that condition, find the value of x. Solution. So as quick as you can do this, for 2 by 2 square matrix, you don't need anything, plus, minus, you don't need that. This is already a 2 by 2 square matrix, so you can, right, do that cross multiplication stuff and put minus between them. This, when we introduce this standard sign convention, plus, minus, plus on the first row, is to reduce them to 2 by 2 square matrix and then be able to do that cross multiplication stuff. So in this case, you don't need a plus, minus, plus. Just go straight. This times this, minus, this times this. Equate it to minus 12 and solve for x. Let's go. Minus x times 4 will give you minus 4x. So minus 4x, then minus. Remember, when you're trying to evaluate determinant, there is a follow come minus. After you do this multiplication, you fix minus before you do this multiplication. That minus you are fixing is a follow come minus. In fact, let me use blue shade of marker, the procedure. Then we have minus 1 times 12. Minus 1 times 12 is going to give you minus 12. So this is equal to, this is the determinant. And from the question, we are told that the determinant is equal to minus 12. Solving for this, you have minus 4x plus 12 equal to minus 12. This plus 12 will cross. You know why it is plus 12? Minus times minus changes to plus. Plus 12 crosses to the right-hand side, collecting like terms. You will get minus 12, minus 12. If this plus 12 moves, it will change to minus 12 there. So minus 12 will give you minus 24. So minus 4x equals minus 24. And then the value of x will give you 6. Divide through by 4. Divide through by 4 to get, divide through by minus 4. The coefficient of x to get the value of x. And that is 6. From the options dictated, the correct option is option A. All right, we are moving on. We are done with this particular guy. We are moving on to the next question. Does any one of you have any question here? Okay, not seen any question, which means you are following with what I am doing, right? Okay, so we are done with these 2 questions. Let's move on to question number 3. Finish up with what's on the board so that I can wipe it and we solve question 3. Now, I really urge you, friends, okay, completely resolve. Be resolved in your mind. Get convinced to become a channel member. Become a member of GMAT 41's channel. Like I always said, at least I'm doing my very best for you guys. You have to support GMAT 41. Becoming a channel member, like I said, I have given the options for students to support GMAT 41. either on the platinum level, which is 2,000 naira monthly, or on the diamond level, right, which is 4,000 naira monthly. You decide whichever is convenient for you. Please become a channel member, because soon, you know, as you're doing this, I've been doing my best for students, and you know, right, soon our classes will be only for members, such that if I am to host a live class, you now say that if you want to join, you'll be asked to, you know, become a channel member. So take the advantage now, become the channel member, so that when this happens, you won't be affected, right? You can follow up with the classes. It's not, and I have a wonderful arrangement for you guys going forward. I will soon start informing you guys about it from coming Monday, right? From the, I think, 7th of this April, 2025. I'll be releasing gradual details on what I have in store for you guys. Become a channel member, please. I'm begging you now, I'm appealing to you, so that it doesn't seem as if this channel has, you know, forgotten you guys. I appreciate your subscription. Yeah, I truly do. I truly do. You guys subscribing, it's not easy, right? But subscription alone does not keep the momentum going. It doesn't. Remember, this is an academic stuff. It's not a place for just ordinary fun and, you know, cruise. What is this called? Is it funny stuff? And this academic stuff. A lot of work goes into providing these stuff for you guys, right? It's resources, energy, time. Become a channel member soon. Our live classes will only be available to members of this channel. So if you are subscribed to this and you are not a channel member, you may not be able to join the class. Channel membership is monthly, so you still have a long time to put yourself together and then renew after a month. And I've made it as cheap as possible, right? Okay, guys, let's move on to our next question. I'm going to wipe what I have here, right? Wipe this. The third question we have on the list here, I think this one is based on inverse of a matrix. And we have this. Question 3. If P equals 2 minus 3, 1, 1, what is P inverse? What is P inverse? So if the matrix has been given to you, right? If the matrix is equal to what you have there on the board, you are required to find the inverse of this matrix P. So you see what I told you, when you are being tested by your exams, these professional exams at this level, you are asked to find the inverse of a matrix. They restrict you to 2 by 2 square matrix. They don't bother you about 3 by 3. But for those of you in advanced level, perhaps maybe 100 or 200 level, you're dealing with matrices, and you know, you'll be tested in 3 by 3 square matrix. So you can go further, go to the GMAETS 41's playlist, linear algebra. You'll see video lessons that I actually dealt with this 3 by 3 inverse of a matrix. Solution here. So let's see what we've got. To obtain the inverse of matrix P, remember I told you the formula will be 1 over determinant of that matrix P. 1 over determinant of that matrix P. Then you multiply it by the adjoint of that matrix P. Adjoint of the matrix. When I was establishing all these stuffs, I used A, matrix A. So inverse of A equal to 1 over det A, determinant of A, then times adjoint of A. In this case, the question is given in terms of P, so we'll work with P. Now you see, what are the things we need? What things do we need to find the inverse of this matrix P? We need the determinant, and we need the adjoint. Getting the determinant is simple. Determinant of P, which is, of course, the first thing you want to quickly obtain when you're calculating the inverse of a matrix. This is 2 by 2 square matrix. So to get the determinant, this times this, you get 2 minus this times this. This times this is minus 3. So when you have minus 3, it will not change to plus. So clearly, the determinant of this matrix is 2 plus 3, which will give you 5. I've shown you that already, so I'm going to write it 5. Once again, look at it. This times this, you get 2 minus 1 times minus 3, which will give you minus 3. So it's going to be minus 3. Minus times minus is plus. So this is going to give you 2 plus 3, giving you the determinant to be equal to 5. Very simple, so you don't go stressing yourself in the exam about that. Let's obtain the adjoint of P. How do we get the adjoint of a matrix? Steps. First, find the matrix of minor. Find the matrix of minor. After getting the matrix of minor, find the cofactor of that matrix. Find the cofactor of that matrix. Then transpose that cofactor. Now, just to give you a little idea of what matrix of minor is, I'm going to show you something. Actually, like the minor of this P, matrix of minor P, to obtain it is just simply to switch this guy diagonally. What do I mean? Switch the elements diagonally. 2 will come here, 1 will go there. Minus 3 will come here, this one will go here. That is how you get the minor of a 2 by 2 square matrix. So let's look at this. Matrix of minor of matrix P. I'm using n sub P as the matrix of minor. Is equal to, I've told you, just switch diagonally. So it's going to be 1, right? Then this one goes here. This one goes here. 1. Then this 3, minus 3 will come here. Minus 3. And then this 2 will come here. 2. This is the matrix of minor. But quickly, let me just give you a preview of how we obtain matrix of minor. From here, we have 2 minus 3 and then 1, 1. I am to get the matrix of minor of matrix P. This is matrix P. Now, to get the minor of this matrix, this is going to give us equal to, now watch. Pick these 2. Delete the row, delete the column. You'll be left with 1. That 1 is the minor of these 2. Therefore, that 1 will take the position of 2. That 1 will take the position of 2. Remember, you obtain this 1 by deleting the rows and column of 2. You are left with 1. So that 1 will now replace that position of 2. But take note, if it is a 3 by 3 square matrix, when you pick this one, delete the row and the column, you will be left with a 2 by 2 square matrix. That 2 by 2 square matrix, you find the determinant stuff. This times this minus this times this. For 2 by 2, if you pick this, delete the row, delete the column, you're left with 1. So there is nothing to multiply that you're doing something determinant in nature. Okay, fine. Let's move on. Next, you pick this 3. Delete the column, delete the row of 3. If you pick the column and if you pick this minus 3, delete the column and the row, you'll be left with this 1. So this 1 will replace the position of that minus 3. Fix the 1 here. Next, you come to this, delete the row and the column. If you delete the row and the column of this 1, you'll be left with minus 3. That minus 3 will come to that position. So you see, it's as if you switched it diagonally. Originally, what you have here is 1. Is that okay? Then finally, come to this. Delete its row. Delete its column. If you delete the row and column of this 1, you'll be left with 2. So that 2 comes down here. This is the minor. So for a 2 by 2 square matrix, to get the minor, just switch diagonally. This comes here. This goes there. This comes here. This goes there. Simple as that. Now that I've gotten the matrix of minor of P, I'll quickly get the matrix of cofactor of P. And how do I obtain the matrix of cofactor of P? Simply go to the matrix of minor. We have 1, 1, minus 3, and 2. Then introduce the standard sign convention, plus, minus, minus, plus. Introduce it to that matrix of minor. Remember, this is a matrix of minor, so go to it, which is what I've done here. Introduce plus, minus, minus, plus. Look at it. This gives you the matrix of cofactor. If you simplify this, you are going to get plus times this positive 1. This 1 is positive. It's bearing plus, so that's going to maintain it as plus, positive 1. Then this is negative times positive 1, because this 1 is positive. Negative times positive 1 will give you negative 1. And then look at this. This is negative. The 3 on its own has minus. So minus times minus will give you plus. So this becomes positive 3. Then you come over here. This is plus. The 2 there is positive. Plus times plus still maintains that plus. So this is the cofactor of matrix P. Remember, we are targeting adjoint. I want to wipe this now. You don't need it in exam for a 2 by 2 square matrix to get the minor, right? You don't need this stuff. I just showed you what you really, how we obtain the minor. Having gotten this, we can now get the adjoint. We can now get the adjoint. Therefore, adjoint, adj of P. Okay, let me write it somewhere here. The adjoint of P, therefore, adjoint of matrix P, which is the same as transpose of the cofactor of matrix P. That's transpose the cofactor of matrix P. Will now be equal to, I'll come over to this and then transpose it. Row 1, turn it to become column 1. 1 and minus 1, 1, 1, turn it. Then row 2, turn it to become column 2. So 3 and 2. 3 and 2. This is the adjoint of P, which is the same as the transpose of the cofactor of P. I'm trying to see if I can manage this part of the board to finish it up. Now we can get our inverse of the matrix. I hope this will not cut off. Now let me leave that side. Come over here. Let's round off. Therefore, the inverse of matrix P will now be 1 over the determinant, and the determinant is 5. Then times the adjoint. The adjoint is 1, 3, minus 1 and 2. So this is the answer. It is either your examiner leaves the answer like this, or the examiner will multiply each of these elements by 1 over 5, which is the same as dividing each of these elements by 5. You know, this is a scalar, a number, 1 over 5, multiplying this. So if you do 1 over 5 times 1, you'll get 1 over 5. 1 over 5 times 3, you'll get 3 over 5. 1 over 5 times minus 1, you'll get minus 1 over 5. 1 over 5 times 2, you'll get 2 over 5. So your examiner can take this 1 over 5 inside the matrix by using it to multiply. Let's see the way the options are presented. Let's see the way the options are presented. All right, from the options given here, the 1 over 5 is not outside. It's not outside, so it was taken in, which means that P inverse is equal to, I've told you, 1 over 5 is the same as dividing each of these elements by 5. So that's going to be 1 over 5 for this, come to this, 3 over 5, come to this, minus 1 over 5, finally come to this, 2 over 5. So this is our answer, the inverse of the matrix. So we are done with this, and then let's see from the options given. You may pay attention as I dictate the option. Where is it? Good. Option A, 1 over 5 for the first element. I'm going to read along the rule, so you follow. Row 1, 1 over 5, then 3 over 5. Row 2, 1 over 5, and then 2 over 5. That's option A. And of course, that's not what we have there. Option B, 1 over 5. I'm reading row 1. Then 3 over 5. Then row 2, minus 1 over 5 and 2 over 5. So let us see. 1 over 5, 3 over 5, minus 1 over 5, 2 over 5. Option B is the correct answer. All right. So we are done with that particular question, and that's it. Now I have this next question, number 4. This one is just a simple question here. Nothing is there. Very simple. Let's see. Where is it? Where is it? Where is it? I thought I saw it just now. Okay. Thought as much. So you are given this. If 5, 3, x2, this matrix equals 3, 5, 3, 5, and then 4, 5. The examiner just simply asked, find the value of x. And then we have the options. Option A, 3. Option B, 4. Option C, 5. Option D, 7. And the correct answer from here, you see, these two matrices are equal. Because they are equal, their corresponding elements is meant to be equal. That's what we have here. Although this is placed in a way that only them know what they try to do here. All right. Or if they are equal, then corresponding elements are equal, like I said. But what they wrote here is actually wrong, actually. Yeah, the way they presented this is wrong. It's wrong. But it doesn't matter. Good enough. The unknown they give to us, which is x, has a corresponding number to read. X in this matrix occupies row 1. Oh no, occupies row 2 rather. Row 2, column 1. So it's going to be equal to the element that occupies row 2, column 1 of this matrix, since they are equal. And looking at that clearly, without any waste of time, x is equal to 4. Look at it, and look at it. So from the option provided, option B is 4 as given. So option B is correct. Copy out what you have there on the board. I'm going to wipe it, so round off. You can screenshot to make the process faster. Finish up. Let's see if we can pick 1-2 questions next. I want us to, although I've not seen questions on addition, I don't think. Okay, let's look at one. At least we've got to deal with a question on addition and multiplication, very important. And I'd like to say this. The way you do addition of matrices is the same way you do subtraction. So if I happen to pick any question that, we have to do addition, it covers for that of subtraction also. I'm targeting also the one we'll deal with that will include multiplication. All right, I'm wiping this. I hope you understood how we obtain the inverse of a matrix. Always remember the formula first, then be guided by the formula. Get the determinants, get the adjoint of that matrix. How do you obtain adjoint? First, get the matrix of minor. I've shown you how to get the matrix of minor generally. But for a 2x2 square matrix, simply switch, diagonally switch. Interchange their position, the position of the element diagonally. That's what you do for 2x2. Then to get the cofactor, introduce the special sign convention, plus minus, minus plus for 2x2. Transpose that cofactor. Once you transpose, you have gotten the adjoint. Substitute into this inverse formula and then you get your result. All right, let's round off. I guess this will likely be the last question because this question I saw somehow, some way includes both addition, multiplication, and let's see what we've got. Given, that should be question number 5, yeah. Given the matrix K, which is equal to 2, 1, 3, 4, the matrix K to the power of 2 plus K plus I, where I is the 2 by 2 identity matrix. Identity matrix is, so that's what we have, and then we have the options. The options provided are also in matrix form, like matrix A, that is option A, along the row 1, 9, 8, row 2, 22 and 23. Option B, 10, 7, 21, 24. Option C, 7, 2, then 12, 21. Option D, 6, 3, 13, 20. So these are the options provided. We're going to deal with this question quickly. It's simple. Don't mind what you have there, right? I didn't tell you anything about identity matrix, but I guess let me reveal a secret. Identity matrix was one of the reasons why I mentioned diagonal matrix. Diagonal matrix, that one that the element above and below the main diagonal is 0. The only thing now is that for identity matrix, the main diagonal, the elements there are 1, 1. For example, a 2 by 2 square matrix, the identity matrix is 1, 0, 0, 1. So you can see how the matrix goes. This is the main diagonal. The elements there are 1, 1. Below and above, you have 0. For 3, this is an identity matrix for 2 by 2. I, 4, 2 by 2. If it is 3 by 3 square matrix, the identity matrix for 3 by 3 is 1, 0, 0, 0, 1, 0, 0, 0, 1. This is I, 4, 3 by 3. Once again, the main diagonal, you can see that the elements you have there are 1, 1, 1. Below and above, you have 0. Okay, so I've told you about identity matrix because you need it in this simplification, this term given to you. So from here, we are simplifying K square. Look at the question. Given this matrix, the matrix K square plus K plus I, where I is the 2 by 2 identity matrix is, what do they mean by that? You are given this matrix. They now want you to evaluate the matrix that you can obtain using this expression. Square that matrix K plus add matrix K plus add the identity matrix. And then I told you the meaning of this I, that this I here is a 2 by 2 identity matrix of this guy. Of course, since this matrix is a 2 by 2, the identity matrix must also be 2 by 2. If this is a 3 by 3, the identity matrix will be 3 by 3. Okay, so which matrix would you obtain if you simplify this? All I'm going to do is K squared plus K plus its identity matrix will be equal to, what is my K squared? This is K. It means multiply K by itself. 2 and 1, 3 and 4. K squared, just like in normal maths, you multiply, if something is raised to power 2, you multiply that thing by itself. So this K squared is going to be the matrix K multiplied by itself. Then plus K. The matrix K is 2, 1, 3, 4. And then finally, the identity matrix, I hope this will not cut off, and to likely cut off. Then plus the identity matrix for 2 by 2 is 1, 0, 0, 1, like I explained. So we are now going to simplify this. Multiply this matrix first. How do you know, or how can you know, rather, that a matrix can be multiplied? Because if I give you 2 matrices to multiply, don't just wake up and multiply it. Not all matrices can be multiplied. For a matrix to be multiplied, there is a condition it must fulfill. It must satisfy. If a matrix must, or if a matrix can multiply, then the number of columns of the first matrix, the number of columns of the first matrix must, take note, must be equal to the number of rows of the second matrix. For two matrices to be multipliable, right? For the multiplication to be possible, the number of columns of the first matrix must be the same as the number of rows of the second matrix. If you look at this, we have two columns. And here we have how many rows? 2 rows. So the multiplication is possible. And let me tell you something. Let us assume that we are just solving a question. And maybe what I gave to you is, I'm just assuming. I gave you 2, 1, 3, 4. And I say you should multiply this by, let's say, 1, 5, 2, 0, 9, 8. This multiplication is possible. You can multiply this matrix by this matrix in this order. The order of arrangement of matrix multiplication matters. You don't arrange it anyhow. If the examiner tells you to multiply A by B, you follow that order. Don't go and do B by A. Matrix multiplication is not commutative. What do we mean by commutative? Like order of arrangement does not matter. In normal basic arithmetic, if I give you 5 times 3 is 15. If you do 3 times 5, you still get 15. But under matrix, when two matrices are given to you, please, if you're told to do A times B, don't do B times A. You won't get the same thing. In fact, if you're not careful, B times A might not be able to multiply. You follow that order, right? Because the answer you get from A times B is not the same as the answer you get from B times A for matrix multiplication. And like I said, for two matrices to even be multipliable in the first place, the number of columns of the first matrix must be equal to the number of rows of the second matrix. If you look at this, how many columns do we have? 2 columns. Column 1, column 2. Here, how many rows do we have? 2 rows. Row 1 and then row 2. So you see the number of columns in this first matrix is equal to the number of rows in the second matrix. Therefore, you can multiply them. But hey, look at, what if you interchange this? Say that this should come first and then you're multiplying it by this. This matrix times this matrix. The first place, can that multiplication even be possible? The answer is no. Why? You can't multiply this matrix by this matrix. You can't. But you can multiply this one by this one. Why is it that you cannot multiply this matrix by this matrix? The reason is simple. Check. How many columns do you have? 1, 2, 3. How many rows do you have here? 1, 2. The number of columns in this matrix and the number of rows are not the same if you are using this to multiply this. Therefore, that multiplication is not possible. Anyway, for all this detailed understanding, you can come back to this lesson. At the end of this live class, a copy of this video will be made available so you can still rewatch and listen to what I said. Alternatively, you can slide to the GMAT 41's playlist on this channel. Seek for Linear Algebra Playlist, Mat 201. That is the code used for it. Mat 201/Mat 231. As you click on that playlist, the video lessons will open. Then scroll. You would see what's on matrix multiplication. So you learn everything about how to multiply matrices. So for this guy, you can multiply them. Square matrices of the same order can be multiplied. But don't just use that idea generally. Know the rule. The number of columns of this matrix is equal to the number of rows of the second matrix. Therefore, you can multiply. If you bring this one first to this, you can also multiply because both of them are square matrix of the same order. This is 2 by 2, this is 2 by 2. But suppose the order of this matrix and this matrix, they are not the same. You might not be able to reverse the multiplication. Okay, guys, let's conclude, please, right? Let's conclude. After this question, I think the class will be brought to a close for tonight. So if you want to multiply, this is how you do matrix multiplication. Pick row 1, use it to multiply column 1. Again, pick row 1, use it to multiply column 2. So it's simple, row 1 against column 1 and column 2. Then go to row 2 and repeat the same thing. Row 2, use it to multiply column 1 and column 2 of the second matrix. As you are using row 1 to multiply column 1, result you'll be getting, be adding them. You are using row 1 to multiply column 2, result you're getting, be adding them. If I use row 1 to multiply column 1, the answer I am going to get will occupy row 1, column 1 of my results. Okay, so I think Follow along as I do that. Row 1, 2 and 1 times column 1, 2 and 3. If you are multiplying, watch. It will be the first element here, which is 2. You are using to multiply this column. So it's going to be first element here times first element here, plus second element along the row times second element along the column. Then you add it together. So we go. 2 times 2 is 4. Plus 1 times 3 is 3. So 4 plus 3 will give you 7. So this multiplication, the element in row 1, column 1 of the result will be 7. I have used 2 and 1 to multiply 2 and 3 here. 2 times 2, once again, first element in the row to first element in the column. It gave us 4. Second element in the row times second element in the column. It gave us 3. And we added 4 and 3 to get 7. Now use row 1 to multiply column 2. 2 times 1, first element in the row times first element in the column. You get 2. Plus 1 times 4, second element in the row times second element along the column. 1 times 4 is 4. 2 times 1 is 2. Plus 1 times 4 is 4. If you add, you will get 6. So 6 will come here. Row 1 has done its work against this second matrix column. Move on to row 2 and repeat the same thing. Use row 2 to multiply column 1 of the second matrix and column 2 of the second matrix, following the same order. First element to first element, second element to second element. So 3 times 2 is 6, plus 4 times 3 is 12. If you add 6 and 12, you will get 18. Remember, you are using row 2 to multiply column 1. So the answer you will get will occupy row 2, column 1. Guess I said you're going to get 18, right? But let's repeat it once again. This row against this column. 3 times 2, 6. 3 times 2, 6. Plus 4 times 3, 12. 6 plus 12 is 18. Finally, on this, row 2 times this column 2. Move again. First element here, 3, times first element along the column 1. 3 times 1 is 3. Plus second element in this row, 4, times second element in this column, 4. 4 times 4 is 16. So 16 plus 3 is 19. Remember, since you use row 2 to multiply column 2, the answer you are going to get, which we obtain as 19, will occupy row 2, column 2. Let's repeat it once again for this. 3 times 1 is 3, plus 4 times 4 is 16. You add, you get 19. So how did we get 7, 6, 18, 19? You know, look at it. Row 1 times column 1 produces the answer or the number in row 1, column 1 of this, which is simply 2 times 2, 4, plus 1 times 3, 3. 4 plus 3, 7. Row 1 against column 2. 2 times 1, 2, plus 1 times 4, 4. 2 plus 4 gives us 6. Then move to row 2, column 1, row 2 times column 1. Result you get will occupy row 2, column 1 here. 3 times 2, 6, plus 4 times 3, 12. Add 6 and 12, you get 18. Finally, 3 times 1, 3, plus 4 times 18, 3 plus 16, 19. So we now have these to be added to 2 and 1, 3 and 4. Then add it to the identity element, 1, 0, 0, 1. At least with this calculation here, this multiplication, I have shown you how you can carry out multiplication. So in conclusion, therefore, we now have that this is equal to, let's do the addition and then see. Let's do the addition and see. I don't know if I can squeeze the result here. Therefore, k squared plus k plus I is equal to, now I want to carry out the addition here. And like I said, the way you do addition is the same way you do subtraction of matrices. So if I do this addition, you have known how to also do subtraction. It's just for you to use minus instead of plus. If your examiner gives you a question on that. So I think with this, we have done as good as done with all aspects of the key things you need to know as you prepare for this exam. So we go. How do we add? You add corresponding elements of matrices, or you subtract corresponding elements of matrices. What do I mean by that? Elements that occupies the same row and column. In this matrix, 7 occupies row 1, column 1. 2 occupies row 1, column 1. 1 occupies row 1, column 1. So you see that it's going to be 7 plus 2 plus 1. 7 plus 2 is 9. 9 plus 1 is 10. So this is going to be 10. Then element in row 1, column 2 of this matrix is 6. Element in row 1, column 2 of this matrix is 1. Element in row 1, column 2 of this matrix is 0. So 6 plus 1 plus 0. 6 plus 1 is 7. 7 plus 0 is 7. So that's going to be 7. You know, the result is going to occupy row 1, column 2, because the addition you did is based on row 1, column 2. Now we move on to row 2, column 1. Row 2, column 1, which is 18 here. Row 2, column 1, which is 3 here. Row 2, column 1, which is 0. 18 plus 3, 21. 21 plus 0, 21. Since the addition you did are elements from, the addition you did is based on elements from row 2, column 1. The answer you are going to get, you write it in row 2, column 1. Conclusively, we'll move on to row 2, column 2. Here is 19, here is 4, here is 1. 19 plus 4, 23. 23 plus 1, 24. Since what we added are elements of row 2, column 2, the 24 you are going to get will occupy row 2, column 2. So this is our answer. All right, guys, from the options given here, option A, I will read along the row and then along the column. So, sorry, along the row 1 and then row 2. Option A, 9, 8, 22, 23. That is not the answer here. Option B, 10, 7, 21, 24. 10, 7, 21, 24. So the correct option is B. So the matrix that you obtain from this matrix, if you carry out this operation, the matrix is 10, 7, 21, 24. The other options, C and D, are wrong options, okay? The C is 7, 2, 12, 21. D is 6, 3, 13, 20. All right, guys. I hope you learned something wonderful from this class, and that is a good one. I think I've got to clap for myself, and you too, from your end, clap for me too. All right, clap for me. It's not easy. We've been able to do, once again, a wonderful stuff this evening as always. This is 4 minutes after 12 midnight from here in Nigeria, right? Anambra State, Oka to be precise. And so, of course, it is ideal, understandably normal, that we go to bed now and rest from what we have learned so far. At least we've been able to spend, 1 hour and some minutes. Let's check the time that we've streamed in the class. Yeah, 1 hour, 40 minutes roughly. That's a good thing, and we've conquered this concept of matrices and determinants. You can solve as many other questions as possible. If you encounter any challenge, remember the GMAT 41 is just right here. You want to join our WhatsApp group to know the way our classes are conducted when we have live classes and what we are going to take. There you can drop questions so that we come online and then deal with it. This is the GMAT 41's WhatsApp contact. Send a message to GMAT 41. Send in that message, include your name, where you are contacting GMAT 41s from, and then your level of education, whether you're in secondary school or you are in advanced level university. That will help me to know the group you'll be categorized. Is that okay? For those that have sent their details so far that have not been added to the group, please just be patient. Later today, you're going to be added to our WhatsApp group. And do not forget, see, I'm trying to run a wonderful stuff. This is an online school as it is. There are no two ways about it. Because what I am doing, I come, we pick a topic, we deal with it, summarize it, and then solve question. What else? You want me to ask you of school fees? All right, let it not get to that yet. However, YouTube is a wonderful platform. YouTube is a very wonderful platform. It's a platform where someone can actually learn from the comfort of his own. As a matter of fact, for me, YouTube is a university, a secondary school on its own. To be honest, most of you guys, that you learn a lot from this platform, even as compared to whatever happened. I don't want to say anything following it. Okay, so you can support your favorite creator. It mustn't be me. It mustn't be GMAT41. However, in as much as I do my best and give the best out there, you are the one now to decide who is your favorite creator. Where do you benefit from the most? And if that is the case that you choose me, please support this platform. Become a channel member. To become a channel member, just tap on the join icon on this channel. Tap on that join tab or icon. And then support the GMAT41 on the platinum level. Depending on what is convenient for you, you can even go higher on the diamond level. But I'm okay with the platinum level, at least for now. Which is just 2,000 Naira monthly. Please. I really would appreciate that. Right? And I wish for that. Thank you for connecting to the class, and I wish you a very warm good night rest, okay? And if you must dream about what you have learned, okay? And don't forget to pray to God and helper Jehovah to help you to be able to digest what you have learned, all right? Let him give you his spirit of understanding and a reminder so that you can grasp this point and remember that. Do you get that? Go further. Don't just stop at this. Pick some other questions on matrices, solve them. If you have any question, like I said, you can drop, and the GMAT41 will be right there to respond. Become a channel member for much more benefits. Good night. Promise, good night. You too, sleep well. Thank you. Angel, thank you. Good night. Still have a wonderful night rest too. I'm glad that you let me read out this. Thanks. Thanks so much, sir. I learned how to get identity matrix even though you did not say it in the physical class. Thanks. Yeah, I didn't say it in the physical class. I did in broadcast. Because that's why you see online learning is very important, because you can learn from both sides and at your own pace. So thank you very much. I'm glad that you followed up or you understood what has been done. Good night once again to all of you.